Okay, let's start continuing with the introduction to our 7.1 Law of Science. Now, last time I gave you the proof for Law of Science and also what it means to solve a triangle that basically gets all the 6 components, the angles and the sides. Now, and when will Law of Science come into play? We use law of sines when we have a pair of an angle and its opposite side, then we can use law of sines. Okay. Before I go on, to remind you that your test 4, which is 2 weeks from now, will be, is it really 2 weeks from now? Yeah, I think so, huh? Let me check. Because one of our friend actually reminded me about where was my syllabus? Some possible misunderstanding on my syllabus. Let me check again. Yeah, on our syllabus, your test for Monday, Wednesday class. So, okay, for your test 4 later on, Tuesday, Thursday class will get your test 4 first, and then the Monday after that, Monday, Wednesday class. Okay, now the thing is for Tuesday, Thursday class, please be very aware that right after your test 4, in 5 days, you have your final. While for Monday, Wednesday class, they have 1 week. Okay, so if we see the schedule again, let me write down the schedule. Yeah, let me write down the schedule. So today is May the 20th. We will do 7.1, 7.2. If possible, 9.1. I think I have a typo on our on my discussion board today, and then on the 25th we'll do 9.1 and 9.5. On the 27th next week we will do 9.2, 9.3. Now your test will be on the 3rd. That's your test 4. Okay, now I plan on the Monday or on the Tuesday, I plan to do a conic section. If conic section, but this conic section will not be in your test 4. It will be in your final. Okay, your final is on the 8th. Okay, that's my plan. That's my plan with you. Yeah. Now the thing is, like in the past, I didn't have a chance to cover conic section, but hopefully this time I have conic section in your final. What is topics for your final? The topics basically whatever I cover, everything I cover this semester. Okay, that's for your test 4 and the tentative schedule, but very likely this is what we can follow. Do we have practice test or final? Oh, very good question. Based on the schedule I have, okay, this is the schedule for Monday, Wednesday class. Monday, Wednesday class. This is Tuesday, Thursday class. We have done a test for prep from May the 17th. and also yesterday. We will also have the on Monday, but very likely we will finish that on next Wednesday. Now then, when I say test 4 prep, this is working over past test 4, the test 4 from the past. Now the thing is, on May the 31st, that's a day off. That's Memorial Day. So we don't have class, right? Yeah, we don't have class. And they have their tests on June the 7th. That's their test 4. Okay, now then on June the 2nd for them, they will still have test 4 prep, but this is from going over chapter tests from our textbook. Usually one Monday, Wednesday meeting before the test, I will go over chapter test from our textbook. Okay, now, but if you see the schedule, then I won't have time to go over past finals. That's the thing. Okay, I don't have time to go over past finals because you see, after their test 4, the next day is your final. You see that? Okay, so I don't have time to go over all tests now. Therefore, I asked our SI leader to help me preparing you for the final. Okay, please take a look on our discussion board. Yeah, please take a look on our discussion board. I wonder if this link work. Does it work? Oh, it still doesn't work, huh? Okay. Let me make it work. Give me a second. So I would like you to fill up this survey. If you need preparation for your final, then please help your SI leader, Mr. Malaki, to basically help him decide what is best way to help you. Okay, I already forwarded to him the last 2 finals I gave in my class, and he will go over that with you. Okay.
Yeah. Yes, that survey right there is for the date and time of the final review session. I'm holding that the weekend right before the final exam. So just pick the time that works best for you. If there's multiple times, check multiple boxes, and I'll pick the one that gets the most votes. Thanks, guys.
Thank you. So that's what it looks like. Okay, let me go back to my notes. Any other question about those? Nothing. Okay. Actually, I think I write this wrong here. It should be 9.5. So if I have time today extra after I finish the law of sines, law of cosines, then I will go over binomial expansion. Okay. Yeah, that's the side notes. Let's come back. When do we use law of sines? When we have a pair of angle and its opposite side. So either this pair or this pair or this pair, then we can use law of sines. Now, before I really start with some examples, let's put two important notes. Maybe make it big. Two important notes when we do law of sines. Okay, first one, law of sines may give two angles when we try to solve for angles. We will try to eliminate anyone. Second, sum of interior angles of a triangle is 180 degrees. Okay, now so if sum of any two angles is more than 180, then we eliminate that option. This one is actually quite easy to see. Now, the third one is not really that easy to see. There's a theorem that we learn in geometry that says the following, that the longest side in a triangle corresponds to the largest opposite angle. The shortest side corresponds to the smallest opposite angle. Basically, the longer the sides, you can draw any random triangle. Okay, and you will see that the longest side always correspond to the largest angle. Okay, and the shortest side always correspond to the smallest opposite angle. Okay, now that's the observation that we use from a theorem back in geometry. Okay. Let's see how we will use it. Let's start with question number 1. Question number 1. Now get ready with your calculator and make it in degree mode. Okay, number 1. angle alpha equals to 52 degrees, angle gamma 65 degrees, and side A is 23.7. Now, I try to structure it this way. So in other words, I write the angle and the sides on the top of each other, like that. Okay. That way, then we can see clearly if we have a pair or not. So it's really also about the way you write it. Now, then to solve this triangle, I think finding angle B is the easiest for now, right? Because alpha plus beta plus gamma equals to 180 degrees. That one is easy, right? Okay, so 52 degrees plus beta plus gamma 65 degrees equals to 180 degrees. So beta is 180 minus 52 minus 60 degrees. What's that? That's 68 degrees. Okay. Oh, by the way, I strongly recommend you to give the heading like this, to prompt us, and including you especially, to, 65, thank you, to prompt us what you are actually working on. Okay. So otherwise, then your work will look like, oh, what you are actually working on here, you know? Okay, so by writing this B and then colon with underline, you are telling me and yourself that you are trying to solve for this for now. Okay, so I get 63 degrees. Thank you for correcting my 60 becomes 65. Okay, now from here, then we notice later on our sides, the longest side will be side C. Why? Because that's the correspond to the greatest angle. Okay, that's the opposite side of the largest angle. Okay, and side C must be greater than 23.7, right? Because the angle 65 is greater. In fact, angle beta, which is 63 degree, we just found out, is greater than angle alpha. So side B will also be greater than A. Okay, now you will see that's actually something you will get through law of sine, even without such observation. Okay, even if you don't observe this, you will see that's automatic. Okay, now the thing is later on, there will be cases where when we try to find the angles, we end up with two angles and we wonder if both of them are correct. Okay, that's for other case later on. Let's do side C first. Side C, so I will use sine alpha over A equals to sine gamma over C. I have a habit, this is for me, I have a habit of writing down the formula first and then plug in numbers. Can I just go ahead with plugging numbers into the formula, Thomas? I don't mind. Just be very careful. Okay, just be very, very careful not to plug incorrect numbers. You see what I mean? Okay, because if you plug incorrect numbers, then of course your solution will be wrong, right? But who knows that the solution that you get later on, let's say in this case in part C, side C, the solution C that you get is wrong, and you need to use that in the follow-up computation, then that part will be wrong also. My instructor, I learned trigonometry when I was in 9th grade. Okay, no, I'm not saying that, whoa, you know what, I'm smart. No, that's not what I'm trying to say. You know, I'm not that kind of person. Okay, I learned it in middle school, back in Indonesia, my ninth grade, and we learned trigonometry in 3 months, not like you in just like 1 month. Okay, now my teacher always say this. She's someone who give you partial points. Okay, as if you show work and the work is correct, of course, then she will give you partial points. She focus more on your work than your final answer. But when it comes to geometry or trigonometry, she emphasized one thing: write your formula down, then plug in numbers. Because if you happen to plug in incorrect number, let's say, for example, this one, you didn't write this down, right? Let's say you didn't write this down, and then all of the sudden you happen to plug in incorrect numbers here, then she will basically penalize you all the points starting from that question and all the follow-up question. That's what she did. Okay. Basically she said, you want to skip that, writing that formula down when it comes to geometry or trigonometry, go ahead. But do it at your own risk, because if you write any informations down, and this is not miscomputation, this is typo. Okay, this is typo. Now, she just said that if the typo is caused by your arrogance of not writing formula down first, at least try to be careful, then I will penalize you all the points from there. Okay. Now, mind you, we were in middle school, so it was like middle school. We were rebellious, teenage, right? Okay, so we still try to show that, oh, you know what, I can do this. But trust me, even though at that point I consider myself an able math student, I did well in math already at that time, but I felt the pain of her sting before. It's like, imagine a I have a quiz in which I make mistake in number one, and all 9 questions after that related to number one. So she just cross that out and then just do this like that and then put a 0. She didn't even want to continue grading it. That's her. Oh yeah, thank you very much. Uh, that's right. That's right. One student actually brought this to my attention yesterday, that I wrote a wrong formula on my May the 11th lecture. This one on section 6.4. On section 6.4, my formula 3b was incorrect. I wrote 1 minus sine theta over cosine theta. That's actually, but actually, I think at that time I was just like, my mind somewhere else. I didn't even read about that. The formula is supposed to be 1 minus cosine over sine over sine. Okay. Now, I really thought I was actually surprised when that student brought it to me. It's like, oh, how can I make such a silly mistake? Because I did memorize this formula, and then I checked if I actually use a wrong formula, and it turns out that no, I didn't. I didn't use a wrong formula. Okay, so in other words, I wrote the formula incorrectly here. It's supposed to be this one, but right after that, here I used the correct formula. You see that? Okay, so yes, I wrote wrong formula, but when I used that, I didn't use that wrong formula. I used the correct one already. That's why I can say, sorry, hey, it must be because I was absent-minded when I wrote that formula there. Okay, but please correct your notes if you took notes. I already corrected the notes I post on the discussion board. Let me show you. On the discussion board, May the 11th. May the 11 discussion board for 6.4. Yeah, I already corrected that. Okay, only that part is incorrect. And to be honest with you, I was surprised with my mistake there. Okay, but I was very happy at the same time because I knew it yesterday. That student brought this to my attention yesterday, and this was 1 week, right? Already, right? But somebody actually went over my notes and compared that with the textbook. That's how he actually found out that I make a mistake. Okay, I was like, oh wow, somebody actually what you call that? Reading my notes. You know, to say that in the negative way, which is not true. Somebody fact check me. Somebody fact check me, but that's okay. That's okay. If I was wrong, you need to let me know. Especially it's a formula. Okay, it's a technical mistake. It's a technical mistake. When I say technical mistake, it's like no, that's not the technique I should teach you. Okay, I have to correct that. If it is just a typo, like for example, the one I wrote here, the 68, because I wrote it wrong here. Okay, that's just typo. Okay, in other words, whoever it is reading that will be able to catch my mistake, right? But technical mistake, like a wrong formula, that's something you will not be able to catch. Okay, yeah, thank you very much for that, student. It's actually Cube the one found it. Yeah, Cube is the one finding it. Yeah. Okay, let me continue with this. So this one, I continue with my computation, but make sure you check the mode of your calculator to be in degrees, okay? 23.7 sine 65 divided by sine 52. Now make sure you use your calculator to check. 27.25787. Is it okay? So let me copy that down. 27.25787. 5 decimal places. Now then, next I will work on B. How to find B? I will do the same thing. Sine alpha over A equals to sine beta over B. I write down the formula first and then plug in numbers. When my instructor, the one I said that, oh, if you don't write the formula down and you happen to plug in incorrect numbers, I will penalize all the points possible from that point on for any question, follow-up question requiring that result. And at that time, I was like, why do you need to do that? It's like, you can tell if I did it right or not, okay? That's the way I thought at that time. And then once I start being a teacher myself, then I realized that one of the hardest thing that I need to correct from a student is the arrogance. The arrogance of thinking that I will be fine if I don't write it down. Okay. Now, I'm not saying students are arrogant. Some students are, including me at that time. Okay. So, and honestly, I'm glad that she actually did that. And basically, I got a 0 in my quiz. That was actually the second or the third zeros I have in my quiz, math quiz. We have math quiz basically on daily basis there when I was in middle school. And it hurt me so much. It hurt my pride, especially. It's like, what? I got a 0? What happened? And it's because of that one silly mistake. And the way she sees that, it's like, no, that's not a silly mistake. That's an arrogance from your side. That's what she was trying to tell me. Okay, and it's like, no, it's, you may have the brain, but with your arrogance, you actually mess up the whole work. Okay, how about being careful? And it's not for anybody else, it's for you, Thomas. Basically, that's what she tried to tell us, because at the end, okay, nobody will people will praise you, Thomas, if you get 100, but nobody will feel sorry for you if you get a 0. In the end, it's about you. Why you worry about what other people say? Because I was so arrogant that I tried to show other people, hey, you know what, I can do that problem in 1 or in 2 steps. That's me at that time. And she was the one who said, nah, it doesn't matter how many steps you take as long as you get it right. Okay, so get it right first, then you learn how to make your step more efficient. But make sure it is effective first. Effective that you get the right answer first before you make it like what is the shortest way to get that answer. Okay, and she was the one who actually said to show us that you may think that showing less steps is better than showing more steps, but you may write less number of steps but takes longer time to solve it compared to taking more steps but shorter time. The way we sometimes think is like, if you have only 3 steps, then you must take less amount of time compared to if you take 5 steps. It turns out that's not true. After all, that's what freeway for. Okay, you may live here, you are going to here, and the local have a lot of stop signs, right? Now, instead, you may take a freeway, a longer distance, but faster to reach. Now, which one you choose, right? By the way, just common sense. Which one do you choose? Going freeway, even though you make longer distance, or going local with a lot of stop signs? Which one you choose if you drive? Okay, the answer is freeway. Okay, but Thomas, freeway cars actually driving fast. Well, if you are careful, right? After all, when you drive local, don't tell me that you drive 25 miles per hour all the way. Huh, yeah, right. Okay. The probability of having accidents on freeway is actually pretty much the same to probability of you having accident on local. Okay. But on local, you have extra risk. With this many stop signs, you just need 1 stop sign and 1 police to get a ticket, right? If you don't stop properly. And that happens a lot in Santa Monica area, like on Ocean. So this is SMC on Ocean Street and 20th. There's a stop sign there, right? Okay, there's a stop sign there. That's like every time I pass there with somebody else. Okay, let's say 7 out of 10 times that person don't stop; they just go through the stop sign. And I almost get hit many times, especially in the evening. Especially in the evening, if I teach evening class, I have that. Well, sorry to go out of topic, but it's just like, hey, if you think that you skip steps and you will be fine, the answer is no, not all the time. Okay, good thing I learned that life lesson actually from math. Strange, huh? Okay, let me compute this. I get 26.79767. And then I fill in this table. Do I have to do this table, Thomas? No, you don't. No, you don't. But if I were you, I will do that. Why? Because the first purpose of this table is to show what I know in structural way. And earlier, I knew that I can use law of sine because I have a pair, right? Another reason is so that you know what you know and you know what you don't know. Okay. Many times, including in our daily life, we know what we need to solve, but we don't know what we are given. Okay, what resources we have. Now, number 5. I will not do it in full. I will just show you the idea. We have 42 degrees, 10 minutes. And side B, 19.7. And then angle alpha, angle gamma, 61 degrees, 20 minutes. So we need to find out side A and then side C. Okay, now using 180 degrees angle, then I can find angle beta, right? Okay, so I just do some fast scratch work here. So beta will be 180 degrees minus alpha minus beta minus gamma. That's 180 degrees minus 42 degrees 10 minutes minus 61 degrees 20 minutes. Okay, now then change this 180 degrees to 179 degrees 60 minutes. And then you subtract there. You see what I mean? Now, the thing is, when you try to find angle A or side A or side C, let's say I look for side A, okay, you have sine alpha over A equals to sine beta over B, right? Now, you need to change this into full degrees. So this will be alpha equals to 42.16667 degrees, while gamma will be 61.33333 degrees, and of course beta also. Now you may want to change this DMS style, degree minutes style, to full degree with decimal in advance. So instead of dealing with them with DMS style, you make it into full degree with decimal at the beginning. Okay, so but if you think about it, the original question has no pair. We don't have any pair, right? We have this angle, we have this side, but we don't have this angle. However, we can find this easily by using this formula, right? Then now we have a pair. Once you have a pair, then you can use law of sines. Okay, that's the plan. The work will be very similar to what we did earlier, except that you still need to convert them to decimal in degrees. Okay. Oh, number 7. That's an odd number, so I do expect you to actually work it out. Okay, number 7. We have gamma equals to 81 degrees. Side C is 11. Side B is 12. Now solve this triangle. Now, of course, the only thing I can do at this point first is to find angle B, right? That's the first thing I will do. Okay, once I get B, then I will find angle alpha. And then from there, I find side A. Is it right? That's the only way I can do. Now, so that's the plan so far. To find angle beta, I will do sine beta over B equals to sine gamma over C. Sine beta over 12 equals to sine 81 degrees over 11. sine beta equals to 12 sine 81 degrees over 11. I get sine beta equals to 1.07748. Now the problem is this is greater than 1. Therefore, no such beta. Therefore, no such triangle. Okay. Why no such angle, Thomas? Why no such beta? Notice that sine theta has the range between -1 to 1 only. Okay. So once you have sine of an angle to be more than 1 or less than -1, then there's no such angle. Okay. So from here, how to solve this triangle? Well, no solutions because even when I did beta, there's no such angle. Okay. Number 13. Alpha equals to 47 degrees 20 minutes. Let me just make it 47.3333 degrees. And then side A is 130, oh, hold on, 86 point. That's 86.3. And we have side B equals to 6.12. Find angle beta, angle gamma, and then side C. So we will do it in this order. Using law of sine, we will get this first. After having beta, alpha and beta will give us gamma. Oops. And then after we get gamma, we can get side C. Okay, at least that's the plan that we will do. Now, let's take a look. Okay, solution. Sine alpha over A equals to sine beta over B. Sine 47.3333 degrees over 86.3. That's equals to sine beta over 6.12. Okay, let's do the computation. So sine B is equal to, sine beta is equal to 6.12 sine 47.3333 degrees over 86.3. 6.12 sine 47.33333 close parenthesis divided by 86.3. Am I looking at the correct situation? I think my number 13 is incorrect. No, the beta is, see, my B happens to be from number 12. So it should be supposed to be 77.7. Change this. This is 77.7. 77.7. 77.7. let me continue. Then sine beta is equal to 77.7 sine 47.33333 divided by 86.3, I get 0.66203. Now the thing is, there are two angles that give you that value. Okay, there are two angles that give you that value. Now the first angle, B1, must be in quadrant 1. Okay, and therefore I will just say that's sine inverse 0.66203. Right? Remember, sine is positive in quadrant 1 and 2. Okay, now so sine inverse of that angle is 41 something. 41.45516 degrees. While beta 2, the angle in the second quadrant, must have beta 1 as the reference angle. That's 138.54484 degrees. Okay. But before we go on, let's check if any one of these two may be eliminated. So remember my note here, law of sine may give two angles. That's what happened just now. Okay. And you will try to eliminate any one of them. Okay, you will try to eliminate any one of them. Now, first one, you see, one of the angle is 47 something. 47 something plus 138 something, that's already 185 degrees something, right? More than 180. So I have to eliminate this one, right? Does it make sense? You see what I mean? Okay, why do I eliminate that? Well, because alpha plus beta 2, alpha plus beta 2 is already more than 180 degrees, right? Okay, if somebody asks you the reason, this because this notation means because. If you see this notation means so. So I usually say so, blah, 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 right? Okay, in mathematical notation, you can also use this. Now, because blah, 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 you may also use this, the upside down of those three dots. Like that. Okay, well, anyway, you usually see that in analysis though, like on the third year of math course, the third year or the fourth year. For now, it's not that I don't know that. I just like, hey, no need. Okay, the reason I cancel that because alpha plus beta 2 is already more than 180 degrees. Okay, that's why I cancel that. But there's another reason why I cancel that answer. Okay, now notice that side A is longer than side B. Okay, so from there we know that alpha, angle alpha, must be greater than angle beta. Right, so we do expect angle beta to be less than 47 degrees something. Does it make sense? Okay, so there are actually two reasons why we reject beta 2. Okay, there are two reasons why we reject beta 2. Okay, also because A is greater than B, therefore alpha should be greater than beta 2. Okay, so there are actually two reasons why we reject that. Now, for that reason, then we have only one angles for beta, that is 41 point something. That's 41.455 5516 degrees. Now, using that, I go on. This is to find beta. I will go on finding gamma. Okay, gamma equals to 180 degrees minus alpha minus beta. So 180 degrees minus 47.33333 minus 41.45516. That is 91 something. So this will be 91.21151 degrees. Now then, side C, as you expect, I will use sine alpha over A equals to sine gamma over C. Gada bum, gada boom. You will get C equals something. Okay, now then, last question from the computation part before we do some word problems. Let's see number 11. The reason I skipped this number 11 earlier because we have ambiguous situation. Number 11, gamma equals to 47.74. Side C is 97.84. Side A is equal to 131.08. Now we will be looking for alpha, and then after that beta, and then after that side B. Okay. Solution. Let's find alpha first. Sine alpha over 131.08. Notice I just plug in numbers. Okay. So if you do so, will you penalize me, Thomas, if I don't write the formula first? No, it's not about that. I will start penalizing you big time if you don't write the formula and you plug in wrong numbers. Okay. So as long as, if you want to skip that writing the formula down, it's fine. As long as you are being careful with plugging in numbers. Usually, what usually happens is like you rush and then you make mistake. Okay. The faster you try to do things, the more likely you make mistake. That's the problem. Same with driving. The faster you drive, the more likely you get into accident. So will you always get into accident if you drive fast? No, it's not. That's not true, but it's because of the probability. Right? Okay, so sine alpha equals to 131.08 sine 47.74 degrees over 97.84. By the way, this second step here, I do require you to write it down. Okay, don't just come up with like, oh, this is what I use, and then boom, I get sine alpha equals to what right away. No, you need to show me how do you get that sine alpha. Okay, 131.08 sine 47.74 divided by 97.84. I get 0.99154. So alpha 1 the angle in quadrant 1 will be inverse sine of that number. And write it down. Write it down. Okay, so that's 82.54249 degrees. And then the angle in quadrant 2 must be the supplement of that. That's 97.45751 degrees. And there's no way for us to eliminate either one of these because first, notice that angle alpha 1 with gamma, it's less than 180 degree, and alpha 1 is bigger than gamma, as we expect, because side A is longer than C. So this solution qualified. In fact, this solution also qualified. Okay, I cannot eliminate either one of them. Okay, I cannot eliminate either one of them. So what do I write here, Thomas? Then I will write alpha 1 equals to 82.54249 degrees, and alpha 2 is 97.45751 degrees. Okay, now then from there, I will look for beta 1, beta 2. You see what I mean? You see how I do the structure? In other words, given this side A, side C, and angle gamma, there are two possible angles for alpha. Okay, and because there are two possible angles for alpha, then there will be two possible angles for beta. Okay, so beta 1 will be 180 degrees minus 97.45751 degrees minus 47.74 degrees. No, that's actually beta 2. Yeah, the number I put here, that's beta 2. That's 34.80249 degrees. And beta 1 is 180 degrees minus 82.54249 degrees minus 47.74 degrees. That's 49 something degrees. Now later on, when we find our side B, you will have B1 and B2. Okay, you will have B1 and B2. So let's do that. Side B. So sine gamma, sine B, let's call it sine B1 over B1 equals to sine gamma over C. So sine of 49.71751 degrees over B1 equals to sine gamma, sine 47.74 degrees over 97.84. So B1 will be 97.84 sine 49.71751 degrees over, yeah, a lot of number crunching, huh? 47.74 degrees. I get 100 something. So B1 is 100.84952. 100.84952. And side B2, side B2, gada boom, B2 equals to 97.84 sine the second angle, what's that? 34 something over sine 47.74 degrees. I get B2 to be 75.45203. This is 75.45203. Okay, now our table is complete. Remember I said that write it in this way. That's the best advice I get from that same instructor. She was the one who tell us, okay, write it this way. Why? This way, then you see what we know and how they are related. Okay, like for example, if you know two angles, then the third angle is given, right? The third, you can find the third angle, for example. Okay, I mean to circle this. If you know two angles, then buy two angles, get one angle free. Okay, and if you have one pair, you can use law of sine. Now let's use this for, let's say, number 23. After that, I will take a break. Number 23. Word problems. A straight road makes an angle of 22 degrees with the horizontal. Basically, the angle of elevation is 22 degrees. Okay. From a certain point P on the road, the angle of elevation of an airplane at point A is 57 degrees. So if you have point P here and you have a plane here, the angle here is 57 degrees. So this angle 57. Honestly, I don't know if that 57 is from horizontal or from that part. Let me just assume that 57 is like this. This is the 57. And then from point Q, let me use Q here. That's 63 from the horizontal. Angle of elevation 63. This is 63. Which doesn't look like 63, to be honest with you. Let me change that. Let me make it like this. I hope that's better. Okay, and the length here is 100. Approximate the distance from P to the airplane. Let's summarize this situation. Okay, so I will just draw that P and Q and A. P and Q and A. This is 100. Then this one here will be 35 degrees, right? And the angle here will be 63 minus 22. That's 41 degrees. Okay, now, can you tell right away what is the angle here? If you have this situation. Can I say that's 6 degrees right away? I wonder if you remember that one theorem in geometry. 41 degrees is this. You see that this angle here is 63. This angle here is 63, but this is 22. Right? That's 22 here. Okay. The same explanation how you get that 35. Now, the thing is, do you know how I get that 6 degree? There are two ways to do that. The first way is this. Well, if this is 41 degrees, then this is 139 degrees, right? And then you see, oh, 35 degrees plus 139 degrees plus what give me 180 degrees. That's one way. That's one way. That's a long way. That's actually a long way. Now, but I think the one that I can insist that you're supposed to know is the fact that the measure of an exterior angle of a triangle is equal to the sum of the measures of the other two interior angle. Notice that the angle here is the supplement of 41 degrees. Right? This angle here is the supplement of 41 degrees, but this angle, the same angle here, is the supplement of the sum of these two angles, right? So they must be congruent, right? Therefore, 41 degrees is equals to 35 degrees plus angle A. Okay. Now then, from that situation, we see, let's write it down. Angle A is 6 degrees. The opposite side is 100. Angle P is 35 degrees. The opposite side is AQ. We don't know that. Okay. And angle Q is 139 degrees. Right? This is 139 degrees. Okay. Side AP is the one we don't know. Okay, now the question is approximate the distance from P to the airplane. Basically, the one in question is this guy here. That's the one in question. Now, how do we do that? Actually, the solution starts from here. I redraw the triangle, but I get rid of those noises. I only write down what information I can use. Okay, so I have sine 6 degrees over 100 is equals to sine 139 degrees over AP. AP, therefore, equals to 100 sine 139 degrees over sine 6 degrees. I get I get 627.63673 meters. Okay. Now that's for law of sine, your suggested homework. From here, I will give myself a break after this. Suggested homework from this 7.1, number 1 to number, I think number 1 to number 19 are good enough. Yeah, you should do 2 word problems. Okay, just do the odd ones. Now, I will take a break. We come back at 9:25. Then we will start 7.2. Okay, let's start again. 7.2, law of cosines. I believe in my lecture video, I gave you the proof. And the proof I give you is actually, the proof I gave there is different from our textbook. Our textbook tried to prove that in using, how to say that, I'm not saying the proof is wrong. I'm just saying that I prefer the other 2 proofs. Okay, I prefer the other 2 proofs. So here's the thing. Law of sines says that if you have a triangle with side A and B, therefore this is angle B, this is angle A, and angle C as the included angle, then side C squared is equals to A squared plus B squared minus 2AB cosine of the included angle. Now, you see that side C is the opposite of angle C. Okay, that's the statement of the proof. Of course, if you permute uh, the variable or the letters, okay, the angles and the sides, then you will see, for example, if you want a squared outside, then this will be b squared plus c squared minus 2bc cosine a. Okay, if you want b squared here, then it will be a squared plus c squared minus 2ac cosine b. Okay, but why the formula is like that? Let's take a look. Suppose all we know are side B, side A, angle C. Okay, the simplest way to show the work here is actually you draw an altitude. Now our plan will be, I will find the altitude here. I will find the length for this part. Let's call that D. Therefore, this guy here will be A minus D. Okay. Now, because this is altitude, then C squared equals to H squared plus A minus D squared. Okay. Now, the thing is H over B is sine C. Therefore, H is B sine C. D over B is cosine C. So D is B cosine C. Now plug those two into the equation now. So this becomes C squared equals to B squared sine squared C plus A minus B cosine C being squared. So C squared equals to B squared sine squared C plus B squared cosine squared C plus A squared minus 2AB cosine C. Now notice that if I factor the B squared here, I will get sine squared C plus cosine squared C plus A squared minus 2AB cosine C. But sine squared C plus cosine squared C is 1. Okay, that's the proof. Now, the weakness of this proof is that, well, the angle is an acute for angle C, even though if you think about it, and then you make the angle C becomes obtuse, it actually works the same way. It actually works the same way. Okay, now that's why to see a more general proof, the second alternative of proof is better. But still, it's not our textbook way. Again, our textbook way of proving it is not wrong. Okay, it's totally fine. It's totally fine. Now, it is as the following. Suppose I have the side here is side what? Side A. Okay, side A. So the coordinate here will be a comma 0. And suppose I have side B here. This is side B. and the angle here is angle C. Okay, angle there is angle C. Now, what I will do is I will find the coordinate here. What is the coordinate here? Now, if you remember from our trigonometry on circle, the x comma y here has the following definition. You see this b is actually the r, right? So x over r is equals to cosine c. Y over r equals to sine c. I hope you remember that. Therefore, x equals to r cosine c. Y equals to r sine c. In other words, now I can rewrite this xy as r, I'm sorry, r, actually the r is b, right? So it's b cosine c, b sine c. Does it make sense? Now, side C that we are looking for is basically applying distance formula on those two coordinates. Okay, d be distance from a comma 0 to xy. Is that right? So d squared equals to x minus a squared plus y minus 0 squared. That is b cosine c minus a squared plus y squared, which is b sine c quantity squared. Now, if you play around, you will get the same thing. Plus a squared plus b squared sine squared c. Now, notice that this guy and this guy becomes b squared, right? Minus 2ab cosine c. Oh, you know what? Let me call that c here, side c. And this is capital C. Okay, that's the proof. Now, structurally, if you look at the structure, notice that side A, side B, angle C. Those are the one given. So basically, if you don't have a pair, you use law of cosine. When to use law of cosines? When we don't have a pair. Okay, if we don't have a pair, then we use law of cosine. Now, when I say we don't have a pair, it implies the following. One of the structure is you have two sides, no two sides, and other angle. It is also possible you actually know three sides. In fact, if you know three sides, then you can use that three sides to maybe I say it this way. Okay, if you know two sides and the other angle, you will be finding the other side. The side corresponds to that angle, right? In other words, if you have three sides, then you can use these two and to get this one with this. Okay, basically, if you know three sides, you will be able to find all three angles. Okay, but using law of cosine, you know two sides and included angle give us the opposite angle, the opposite side. And that's it. That's for this section. It's about the application now. Okay, it's about the application now. Let's see. I start with the easiest one first, number 5. Oh, let me jump to number 7 right away. Number 7. So we have beta to be 150 degrees. The side A 150, side C equals to 30. Okay, now using this, which of the following we need to compute first? Angle alpha, or side B, or angle gamma? The one we can find first is actually side B using law of cosine. Okay, that's what we can find first. Okay, now then from there you can use law of sine to get this one, or this one. Is it okay? But we can find side B first. Okay, let's solve that. Solve solution. Okay, B squared equals to A squared plus C squared minus 2AC cosine beta. So B squared equals to 150 squared plus 30 squared minus 2 times 150 times 30 times cosine 150 degrees. I dump all of them into calculator. I get 31194.22863. Now do the square root. I get 176.61888. Okay, so this will be 176.61888. Is it okay? Now then, using that pair for beta and B, we will be able to find angle alpha and angle gamma. Okay, we will be able to find angle alpha or angle gamma. Now, the thing is, if you use law of sines to find alpha or gamma, you will get two angles, right? You will always get two angles. How do we know which angles? Then just observe what could happen. Now, of course, when we get two angles, let's say for alpha, right? Let me do alpha here. Now, I will show you now that we will get two angles, but we are able to eliminate one of them. Okay, we will be able to eliminate one of them. Okay, because later on when you get alpha 1, alpha 2 will be in quadrant 2, right? Which means alpha 2 is greater than 90 degrees, but that's impossible because the other angle already 150 degrees. Does it make sense? So I will be able to cancel that one. I will be able to cancel alpha 2. Okay, now even if you work on gamma, later on you will have gamma 1, gamma 2, right? Okay, again, gamma 2 will be in quadrant 2, which means gamma 2 is already more than 90 degrees, which contradict with the fact that angle beta is already 150 degrees, it will give you a total of more than 180 degrees. Now, another reason that we can cancel gamma 2 is because gamma 1 has to be the shortest side. Gamma 1 corresponds to the shortest side. So for sure, gamma 1 is the answer, not gamma 2. Okay, this is the case where we will be able to cancel one of two solutions we get. Either we do alpha first, or when we do gamma first. Okay, now let me work it out. I show you one of them and then you will get the other one. So let's find out alpha, and then once I get alpha, you can find the gamma yourself, right? Okay, so sine alpha over 150 equals to sine beta 150 degrees over 176.61888. So sine alpha will be 150 degrees times sine 150 times 150 degrees over 176.61888. So sine alpha equals to 0.42464. So alpha 1 will be sine inverse of 0.42464. That's 25 degrees something. And alpha 2 is 180 degrees minus alpha 1. Even though we know we will reject that, write it down and then reject, and then say why you reject that. Okay, but you cross this out since beta plus alpha 2 is already more than 180 degrees. That's why you reject that. Okay, so angle alpha will only have one option, that is 25.12808 degrees. I believe you can find angle gamma yourself from here. Now the thing is, how about number 15? How about number 15? Actually, before I go too far, let me do this first. Number 11. Number 11. A equals to 10, B equals to 11, C equals to 22. Why alpha 2 is not okay? Because alpha 2, if that were right, alpha 2 is what? 154 degrees, right? Okay, but alpha 2 together with angle beta is already more than 180 degrees, which is not possible for a triangle. Does it make sense? Okay. Then number 11. Number 11. You need to find angle alpha, angle beta, angle gamma. Okay. Now let me use law of cosine first and show you that this is impossible. Okay. Let me use law of cosine first and show you that this is impossible. Okay. But you will see that that's actually a hard work. Why? Suppose I want to find angle gamma. Okay, so c squared equals to a squared plus b squared minus 2ab cosine gamma. Okay, so that's 22 squared equals to 10 squared plus 11 squared minus 2 times 10 times 11 cosine gamma. So this is 484 equals to 100 plus 121 minus 220 cosine gamma. So cosine gamma will be 484. I think I prefer to do it this way. 100 plus 121 minus 484 over 220. Now let's see what's wrong with this. This is equal to negative 1.19545. What happened? I'm sorry. Okay, I get this is equals to negative 1.19545. But this is less than negative 1. So we have no such gamma, therefore no such triangle. Okay, so the answer is actually quite short, right? To reach this conclusion, no such triangle, you apply law of cosine and see no such angle works. Okay, but alternatively, another option, we know a triangle inequality. The sum of two sides of a triangle must be longer than the third one, which is not the case here. Okay. Notice what happened is a plus b equals to 21, which is less than c, which is 22. Okay, that's a violation of triangle inequality. But in a triangle, a plus b, the sum of two sides must be greater than the other side. Okay, so no such triangle exists. See, if you know, and that's the prerequisite for you, if you remember your geometry, you can answer this question easier. I cannot do such trick. I cannot do such manipulation, shortcut, I call that, with my West LA College class because the prerequisite for their calculus is trigonometry. But when they took trigonometry, they didn't have geometry. You see, you have that, so you can do this. Okay, now let's practice with a problem where such angle exists. Let's say number 15. Let's say number 15, we have A equals to 25, B equals to 60, C equals to 80, B is 80, C is 60. Then find angle alpha, beta, and gamma. Okay, in fact, in this situation, you are free to choose which angle you want to do first. You are free to choose which angle you want to do first. Okay, now because we are free to choose which angle to do first, okay, then choose the one, the middle one. You can again, you can find angle alpha, angle beta, angle gamma. You can do it in any order, but the easiest one will be you choose the middle one. Okay, gamma is the middle angle, right? You will see later on that gamma is greater than alpha and gamma is less than beta, right? Okay, so even though you can do alpha, beta, gamma in any order, okay, but if you are to choose, you can be a bit smarter now, like being, I say smart in the sense that we use some knowledge from geometry combined to our knowledge from law of sine. Because if I need to find all alpha, beta, gamma, if I need to find all alpha, beta, gamma, which path will help me finding the angles such that I don't need to deal with ambiguity later on. Okay, so I will find gamma first. Okay, why do I do gamma first? Because gamma for sure must be less than 90 degrees. For sure. Why? In any triangle, there is at most one obtuse angle. Do you agree? You cannot have two obtuse angles. If you have two obtuse angles, the sum is already more than 180 degrees. No way. Okay, so from this triangle here, if you observe, if any angle is obtuse, it will be angle beta. Agree? If any obtuse angle, it must be angle beta. May be obtuse. Is it right? We don't know yet. We don't know. We don't know. Okay, but if any of them may be obtuse, that will be angle beta. Okay. Now then, it means gamma must be less than 90 and alpha must be less than 90 also. So if you ask me to do this, I will do, and in this order, I will do this one first, and then this, and of course, this is automatic, right? Okay, because once I get gamma, when I use law of sine, I may have two angles, alpha 1, alpha 2, but alpha 2 in quadrant 2 should be rejected because it will make it an obtuse. No, it's impossible. Because we know alpha has to be less than 90, cannot be obtuse. Right? Actually, I need to point out to here. I cross this out because of this. Okay. Now, another approach is, I'm teaching you the technique here. I know I'm not doing any computation yet. Another option is, let me erase all of this. Another option is, you find angle beta first, the largest one. So you do this first. Okay. Knowing for sure that your angle gamma and angle alpha for sure acute angle. So even if you use law of sine later on, there's no chance you get alpha 2. There's no chance you get gamma 2. So as a starting point, okay, you can start from gamma, which is my preference, or you can start from beta. Okay, now I do not recommend you to start from alpha. Why? Because your alpha, for sure, if you use law of cosine, for sure that will be obtuse, right? Okay, but then it will not eliminate our possibility for beta 1, beta 2. Okay, if you choose to do beta after that. After you get alpha from law of cosine, if that's your first step, then this should be your second one. And then you get this. Okay, now this explanation comes to our discussion because we have so much freedom, right? We have so much freedom. We can find alpha first and then beta and then gamma. Okay, you have so much freedom such that think about how to avoid having the ambiguity case. Okay, so let me do as I planned. I will find angle gamma first, which means c squared equals to a squared plus b squared minus 2ab cosine gamma. So 60 squared equals to 25 squared plus 80 squared minus 2 times 25 times 80 cosine gamma. Okay, you notice that I spent like around 5 minutes explaining this formula, the techniques. It's because if one day, if you want to have extra income, one thing you can do once you get your bachelor is to teach SAT, even though right now it's not necessary anymore because UC already dropped the need of using SAT, having SAT. I really think that's a bad idea though. I really think that's a bad idea, not using SAT as one of the measurement. Okay, they want to use other measurement, but which I agree it's okay, but getting rid of SAT, that's actually a bad idea. Well, anyway, that's my opinion. Again, that's my opinion. But you will see that in SAT, especially SAT 2B math part, there are a lot of questions there. If you think about that a little bit further, okay, if you think about that a little bit further, you don't need more than 1 minute to do the problems. For example, if you look at this number 15, right? Can you tell what is angle alpha approximately? Well, we know for sure it's less than 90, right? Even gamma already less than 90. Even gamma already less than 90. Okay, but can you see that alpha is actually even less than 30 degrees? It's even less than 30 degrees. Let's check, right? Okay, but in SAT, like when they ask you, okay, you have side A is 25, or let's say they say the three sides of a triangle is 25, 60, and 80. What is the shortest angle? What is the smallest angle? And you have option, let's say the options is 27 degrees, 30 something degrees, 45 something degrees, and then 120 degrees. Can you eliminate one of them by just looking at that? Right? Okay. Either you spend 2 minutes applying law of cosine to actually find alpha, or use your little instinct. Okay, you know what? Because of this, because of that, then it must be this one. Okay. Now I have to really compute this though. Okay, so cosine gamma equals to 25 squared plus 80 squared minus 60 squared over 2 times 25 times 80. Do you know what I did? Welcome to Thomas class, where you need to think harder. This guy go here. This guy go here. And then this part on this side go here. So cosine gamma is equal to 25 squared plus 80 squared minus 60 squared over 50 times 80. I forget parentheses. I get 0.85625. Now, the nice thing about cosine is you will have only one angle. See, if cosine x is positive, and of course less than 1, then x must be in either quadrant 1 or quadrant 4. But this x is an angle of a triangle, so it won't be in quadrant 4. If cosine x is negative and greater than -1, then x must be either in quadrant 2 or quadrant 3, but because x is an angle of a triangle, the angle will not be in quadrant 3. So the nice thing about law of cosine is when you use law of cosine to find the angles, there is no way you get ambiguous case. You will have a unique angles, if any. Okay, so here I get cosine inverse of 0.85625. So gamma equals to 31 something degrees. Huh? Only 31 degrees? Oh, wow. Even I surprised. That's angle gamma. This is 31.10190 degrees. Now then, how to find angle alpha? Sine alpha over 25 equals to sine gamma 31.10190 degrees over 60. So sine alpha is 25 sine 31.10190 degrees over 60. Sine alpha is 0.21523. So alpha 1 is sine inverse of that. Which is 12 degrees something. Or alpha 2, which is 180 degrees minus alpha 1. We know this will be greater than 90 degrees, right? But alpha 2 supposed to be less than gamma, which is 31 something. Okay, that's why you will reject that, alpha 2. Okay, so alpha 1 is 12.42926. Now then, using those two, I will be able to find angle beta. Okay. Now, the follow-up part from this section, area of triangle. Now we know given any triangle, then let's say this is B and this is the height, the altitude, then the area of that triangle is 1/2 base times height. Okay, now if you don't know this formula, quickly drop the class. It's too late. You cannot drop the class anymore anyway. Okay, so that's the basic formula for the area of a triangle. Okay, now, but suppose what we know are two sides and one angle. Suppose I know side B, side C, and angle A, the included angle. Notice that this configuration is exactly the same configuration we started law of cosine. Okay, if you know two sides and included angle, then you can use law of cosine to find the opposite side of that angle, right? Now, but using the same starting points, two sides and included angle, we will be able to find the area of this triangle, okay? Because what? H over C is equals to sine A. So H is C times sine A. Substitute that here. So A is equal to 1/2 B times C sine A. That's the area of a triangle. The product of two sides times the sine of the included angle divided by 2. Okay, now from geometry, we also learn Heron's formula, which I will not prove. The proof is too long. Heron's formula. In fact, I just saw somebody else prove this on Facebook, only using pictures. And I was like, wow, that's the shortest Heron's formula I ever seen. But anyway, Heron's formula say the following: if A, B, C are the sides of a triangle, then the area of that triangle is equals to S square root of S times S minus A times S minus B times S minus C, where S is semi-perimeter. That is A plus B plus C, the perimeter, divided by 2. Okay, now let's use this formula. For example, which one is good? For example, number 37. Number 37, I have alpha equals to 60 degrees, B equals to 20, and C equals to 30. So you see alpha is the included angle of side B and C, right? Notice that I purposely write it in that structure like this. Okay. So the area is equal to 1/2 BC sine 60 degrees, sine alpha. when I plug in numbers, this is 1/2, 60 times 30. No, 20 times 30. 20 times 30 sine 60 degrees. Oh, by the way, 60 is a special angles. So when you compute, you need to use the exact value. Okay, so that will be 150 square root of 3. Okay, now what about if we have number 43, where we have all three sides, 25, B is 80, C is 60. So we don't have any angle. So the area will be square root of S times S minus A, S minus B, S minus C, where the S semi-perimeter is 25 plus 80 plus 60 over 2. That's 82.5. Is right? 140, 165 divided by 2, 82.5. So the area is square root of 82.5 times 82.5 minus 25, 82.5 minus 80, 82.5 minus 60. That's square root of 82.5. What is this? 67.5. Is it right? No, 57.5. 57.5. And this is 2.5. This is 22.5. Use my calculator to compute. And then do the square root. I get 516.56. 516.56165. That's the area of that triangle. But we have a new challenge right now. Suppose we take a look on number 41. Number 41. We have angle alpha, that's 80.1 degree. Side A is 8. Side B is 3.4. Huh. How do we find the area? How do we find the area? Because that's not one of the formulas that given to us, right? That's not one of the formula given to us. We need two sides and opposite and included angle. Two sides and included angle. Okay, now idea. Using law of cosine, we will be able to find angle beta. Is it right? But even with angle beta, we cannot do anything yet. We cannot find the area, I mean. Now, once we get angle beta, then we can find angle gamma. Okay, now once you have angle gamma, then you have two sides and included angle. You see? Does it make sense? Okay, now, more to say. more to say. Side A is greater than side B, so angle alpha, which is 80 degrees something, must be greater than angle beta. So that's the case of we will not have beta 2. Okay, we will have only beta 1. Okay, we will have only beta 1. Now let's work this out. Solution. We'll first find beta. Sine 80.1 degrees over 8 is equals to sine beta over 3.4. So sine beta is 3.4 sine 80.1 degrees over 8. Three 3.4 sine 80.1 degrees divided by 8. That is 0.41867 equals to sine B. So B1 is sine inverse of 0.41867. That's 24 something. And beta 2 is 180 degrees minus beta 1, which is greater than 90 degrees, but A is greater than B, therefore alpha must be greater than beta. So beta has to be less than 81.1 degrees. That's why you will cancel that. Okay, so your beta now is 24.75074 degrees. Now then from there we use to find angle gamma. Angle gamma is equal to 180 degrees minus 80.1 degrees minus 24.75074 degrees. We get 65.14926 degrees. So the area equals to 1/2 times 8 times B. Maybe I write it down. Sine 65.14926 degrees. Okay, so that's 4 times 3.4 sine of that 65 degrees something. I get the area is 12.34072. Okay, and your suggested homework from here will be (7.2), number 5 to number 17. Try number 19 and number number 28 is actually a good one, but that's an even number. There's no way to check that. How about, oh yeah, and then 37 to number 43. Okay, Now on Tuesday, when we come back, we will start working on, I will do 9.5 first and then 9.1. Okay, on Tuesday, when we come back, we'll do 9.5 and then 9.1. Okay, see you then on Tuesday. Start studying for your test. Start studying for your test. Okay, the video already there though. From Monday, Wednesday class. Thank you.
Thank you.
Welcome.